We're going to look at doing a definite integral by trig substitution. And what we look at is the form. So what causes the trouble in this one is this x squared plus 1 under the radical. U sub is not a possibility, but that x squared plus 1 form is similar to this x squared plus a squared form, which means we'd want to use a tangent theta. So let's see how that works out. So, we already know what our substitution is going to be. Let x equal, a in this case is the square root of 1, so it's just x is tangent theta, and immediately after you've identified your x, find your dx, which is secant squared theta d theta. You don't want to ever forget your dx. Now, let's go put these pieces in here. So, we have a tangent theta cubed, and then under the radical we've got a tangent theta squared plus 1, and then we got to remember to substitute in our dx. It's equal to secant squared theta d theta. Now notice I haven't done the limits yet. This is a definite integral. When we do a definite integral, I always recommend switching the limits to be in terms of your variable so you don't have to switch back later. Here's the relationship between x and theta. Essentially, these limits are x values. So, to find what those are in terms of theta, the upper is going to be 1 equals tangent of theta, and the lower is going to come from 0 equals tangent theta. Now tangent is 0 at 0, so that means theta equals 0. If you remember, tangent is 1 where sine and cosine are equal, which is at pi over 4. So I'm going to change my limits to be theta values. Now I don't have to substitute back after I've done my antiderivative. Alright, let's simplify and see if we can solve this integral. So we're going to have a definite integral 0 to pi over 4. We have a tangent cubed theta here. We have a tangent squared theta plus 1. By the Pythagorean identity, that's actually secant squared theta. And we've got a secant squared theta and then our d theta. So once we've simplified, and I should be putting equal signs, it's a good habit to always include your equal sign. 0 to pi over 4. Tangent cubed theta. Combining our secants, that's just secant theta with a secant squared theta. We got a secant cubed theta d theta. Alright, now this one at first seems like it might get to be a messy integral, but there's something interesting to notice about this one. What I would notice is that the derivative of secant is actually secant tangent. So what I'm going to do is I'm going to write this as tangent squared theta, secant squared theta, tangent theta, secant theta, d theta. Not a real obvious move your first time through, but you start to see little things you can do like this. The reason I did that is because I'm now going to do a u sub. I'm going to let u equal secant theta. And thus my du is secant theta, tangent theta, d theta. So I'm going to be able to sub for the secant squared and the tangent theta, secant theta. Now the only thing I'm not quite going to be able to substitute for is the tangent squared. But remember, by the Pythagorean identity, tangent squared theta is actually equal to secant squared theta minus 1. So you see that the Pythagorean identity plays very heavily in trig substitution. Now, we've got our integral. Right now it's in terms of trig function, so I'll keep that, but we will be changing that. So secant squared theta minus 1 times secant squared theta tang theta, secant theta, d theta, kind of long. It's going to work out really nice. This part here, well, that's our u. We got u squared minus 1. Secant, again, is our u. So u squared, this whole thing here, that's our du. So we have a much nicer integral. Now, the other thing we're going to do, remember that I changed the limits to be in terms of theta when I substituted in theta. Now that I'm putting in u, I'm going to have the limits be in terms of u. So that means my lower limit is the secant of 0, and my upper limit is secant of pi over 4. Secant of 0, that's 1 over cosine of 0, which equals 1. Secant of pi over 4, that's 1 over cos of pi over 4, which is rad 2. The nice thing about that, this is now my definite integral. The only goal I have left is to solve this thing. That's going to come from distributing the u squared. So 1 to rad 2 of u to the 4th minus u squared du. And now, taking my antiderivative. U to the 5th over 5 minus u cubed over 3. It's a definite integral, so no need for the plus c from 1 to rad 2. I'm going to go across here and plug in my values. So, I've got rad 2 to the 5th over 5 minus rad 2 to the 3rd over 3 minus 1/5 minus 1/3. There's not a ton of simplifying we can do in here. We can match up some like terms and get this thing down to 4 rad 2 minus 1 over 5 plus 1 minus 2 rad 2 over 3. Or if you wanted to see it as a decimal, it's approximately 0.3218951,416 if you wanted to compare it with a calculator. So that's one way of handling it when you have a definite integral that involves tangent in a u sub.